All right, so what we hope is a corn farmer or something. All right, we hope he doesn't have wild animals roaming around the highway. But he has 2,000 meters of fencing and wants to enclose a rectangular plot that borders on a straight highway. Yikes. So if the farmer does not fence in the side along the highway, what's the largest area that can be enclosed? All right, so it's kind of like the one that we had yesterday, and kind of like the one I warned you about. Well, actually, didn't you guys have the alligator problem? Okay, so you guys had that one. So it's a lot like that. So we know that the area of my rectangles are going to be length times width. So if I let this be x, right, how much fencing do I have left over for the other two sides? 2,000 minus x. And then, but I have two sides that are equal to distribute that over. So what do I do with that?
You 1,000 minus
Close. I have to divide all of it by 2. So it's going to be 1,000 minus 1/2 x. Okay, so each one of these is going to be 1,000 minus 1/2 x. All right, so if I want my area, though, then with only x's in it, it's going to be length, x, times width, 1,000 minus 1/2 x. So when I distribute, I'm going to get 1,000x minus 1/2 x squared. And now I can figure out where my area is going to be at a maximum. It's not going to be a square this time. So what's my b in this problem? 1,000. So I'm going to have the opposite of 1,000 over 2a, negative 1/2. So I get 1,000 over, well, negative 1,000 over a negative 1. It's positive 1,000. All right, so this, man, could have picked a better color than green, is 1,000. So I have 1,000 left over to distribute over each of my two sides. So what are they? 500. Okay, the question was, what's the largest area that can be enclosed? Multiply them together. So 1,000 by 500 is going to give me 5, 3, 2, 500,000. And then what was this in meters? Square meters. Right, a parabolic arch. Right, so you've got two different kind of bridge problems. You're going to have the suspension bridge problems where the stuff comes down like this and you have your parabola that way. And then you have this kind of bridge where the parabola is underneath the bridge. Right, so this one's a parabolic arch and it spans 120 feet. And a maximum height of 25 feet. Choose suitable rectangular coordinate axes, and then find the equation of the parabola, then calculate the height of the arch at points 10 feet, 20 feet, and 40 feet from the center. Okay, well, here's my axes, right? Where do I want to put my origin? I only have so many places to choose from. Well, where on my arch? I could put it here, I could put it here, here. This might be a good one. Any of those. Which one did you guys pick? So where the blue is, where the blue lines meet? Okay. And actually, pretty much all of those places are okay. It's just going to change how we come up with the formula, so it doesn't really matter. But this one's as good as any. All right, well, all right, what does, now my formula looks like this. Oh my. All right, so, well, that means that my center, or not my center, we want my vertex. So where is my vertex going to be? This is a coordinate system. How far over on my axis?
0.
0. How far up? 25. So that's going to be what I've got so far. So I've got a times an x minus 0 squared plus 25. All right, so in other words, y equals a times x squared plus 25. Now, I need to figure out what a is going to be, so I would need some point on my parabola. Can I get one? Well, this whole span is 120. How far over is this? And then that means this one's going to have to be at negative 60. All right, so this point over here is 60, 0. And if I put, and that's definitely on my parabola. So if I plug in that 60, 0 in here, I'll be able to get some sort of A. All right, and then I want to know how many times 25 goes in there. 144. So I'm going to get negative 1 over 44. Now, does it make sense that my A is going to be negative for this parabola? How come?
Because it's going down.
Yeah, it's a parabola that's opening down anyway, so that makes sense that it better be negative. All right, so now we know that my formula is y equals negative 1 over 144 x squared plus 25. All right. Easy enough. So that's the formula that I have, and we'll just do one of these. So if I wanted to figure out how high the arch was at 10 feet, then I plug in 10 and see what kind of y I'm going to get out. So y equals 1 over 144 times 10 squared plus 25. All right, so I'm going to get negative 100 over 144 plus 25. Let's see, that's probably going to simplify. Does this seem right? Better. All right. Oh, and this is negative. So it's actually not going to be that much lower. It's going to be 25 minus whatever 2536 is. So I'm going to get 24 and 936. So 24 and a quarter feet tall. So it didn't really come down all that much. But the further I go out, the more it's going to come down. Right? And then if I wanted the 20 feet, I just plug in 20 in for my x. If I wanted the 40 feet, I would plug in the 40 for my x. Right? But the key was coming up with an equation that I could plug things into. So that was the main thing that you needed on that one. All right. A Norman window has the shape of a rectangle surmounted. Are you guys going to use the word surmounted today? You should. It's a good one. All right, surmounted by a semicircle of diameter equal to the width of, I think that's supposed to be the rectangle. All right, so, oh no. Well, it's just going to have to stay as it. All right, if the perimeter of the window is 20 feet, what dimensions will emit the most light? So basically, we want to maximize area of our window. This is kind of like the wire problem, sort of. Right? So they tell me that I've given you a hint here of circumference of the circle is 2 pi r, and the area of the circle is pi r squared, and r is going to be the radius of the circle. So we need we need to figure out what that's going to be. All right. Well, we know that the diameter equals the width of the rectangle. And if the perimeter all the way around is 20 feet, we need to figure out the rest. So basically, for my rectangle here, we've got, we know that that's going to be a length times a width. And then we need to add on, so my area total, let's do it this way, equals the area of the semicircle plus the area of the rectangle. All right, and we just need those to both be in terms of the same variable, what variable you want to use. X. Okay. R. Okay, let's use R, because most of my formulas have to do with that R. All right, so now, how do you find the area of a rectangle? All right. Okay. And then what's the area of a circle?
Pi r squared.
Semicircle? Half of that. So we're going to have 1/2 pi r squared. All right, that one's already got r's in it. So now all I'd have to do is figure out length and width in terms of r. Now they're telling me that the width of this thing is the same as the diameter. So what's the diameter of a circle?
Two r's.
2r's. So that means this is 2r. Well, that means that this is 2r. All right, so we're getting there. I only have 20 feet to put around the whole thing. So I need to figure out how much is taken up by this, my semicircle. So what's the circumference of a circle?
2 pi r.
Okay, but I only have half of a circle.
So just pi r.
So it's going to be pi r. Right? So far, I've got pi r and 2r taken up. How much do I have left over for my other two sides then? Well, let's do it this way. How much have I used so far?
4r plus pi r.
I don't think we're counting this stuff inside. I think that I know that I have it drawn that way, but I think the window is supposed to just all be one window, nothing in between. So 2r plus pi r. So right idea though. So if I've used 2r and pi r, how much did I have to start with? 20. So I have 20 minus that left over for my other two sides. And I know that those two sides are going to be equal. So if I distribute my negative through here. So this is how much I have to distribute over these two equal sides. So how do I figure out how much each one is? Divide it in half. All right, and you can do that right now, or you can take this whole thing just the way it stands. Either way, but this is going to be my length. All right, so my area with only r's in it is 1/2 pi r squared plus length times my width. All right, now some good things happen here. This 2 cancels with that 2. And now I can distribute this r through here. I'm going to have 1/2 pi r squared plus 20r minus 2r squared. This was pi r? Yeah. Minus pi r squared. All right, I can combine some like terms together, some of which you may not be able to see right away. But how many pi r squareds am I going to have? I've got 1/2 minus 1. So, negative 1/2 pi r squared minus 2 plain old r squared plus 20r. All right, now here might be the tricky part for you, because I still want this to be looking like a quadratic so that I can plug it into the opposite of b over 2a thing. Now, these two have an r squared in common. If I pull that out of those two, what am I going to be left with? Here.
Negative 1/2
And here?
negative 2.
So what I've got is negative 1/2 pi minus 2. Pi is just a number, so this is just a coefficient to r squared plus 20r. So if I want to try to find my maximum area now, I want to figure out where my parabola is going to top out. And it's definitely going to be an opening down parabola because my a is basically negative. So opposite of b over 2a. In this problem, what's my b? 20. So I go negative 20 over 2 times a. What's that?
Negative 1/2 pi minus 2.
You got it. It's not pretty. It works. So I got negative 20 over, well, I'm going to distribute this through. I'm going to get negative pi minus 4. And this is just going to be some decimal. And it's going to be a positive. So, negative pi minus 4. And I want to go negative 20 divided by that answer. And I get approximately 2.8. All right, now what's that 2.8 represent? It's r. So that represents my radius of my circle, or of my semicircle there. So if I want to come up with the area of the entire window, what do I do with that 2.8?
You plug it back in.
Plug it back into any one of these equations. They're all pretty awful. Let's plug it back into this one. That seems to be the most simplified. So negative 1/2 pi minus 2 times my 2.8 squared plus 20 times the 2.8. This one's 56. This is a 7.84. This is going to give me negative 3.57 times that 7.84. Actually rounds to negative 28 plus 56. And I believe that was in feet, right? Feet. So this is going to be 28 square feet, roughly, of window. Yeah.
That was like super, super confusing.
It was awful.
Is there going to be anything like that?
There might be a problem on there where you have to come up with the area of something with some random shapes. But again, I will give you all the formulas for these. I mean, try to break it down with these shapes, like, and realize what it is that you have. So if you've got a circle, make sure that, or half of a circle, either way, that you're figuring out that your ultimate goal is to find the area and break it up into these parts, and then figure out the area of each one. Yeah, it's a lot like the problems that we were doing before. The good thing is that they're parabolas. Okay, but I can see me doing this, where you have to come up with these and substitute something in. But my guess is if I did that to you, you're not going to be plugging in an A that looks like this. It'll be like a 4. Right. Something that's easy to plug into the formula. All right. Any other ones? Like this one was kind of similar. I like this one. Mainly because it has to do with track. You guys have any trouble with this one? Does anybody need to see this one?
Do you have the answer to that one?
What number was it?
17.
Then yes.